All right, lesson 2.2. We're going to talk about the change in linear and exponential functions. So exponentials are going to be new to us. We haven't seen those before. In my class, you've seen something very, very, very similar in lesson 2.1, but today we're going to introduce what an exponential function is. So with that, let's start first with making a comparison. You've seen me do point slope form of line. As a matter of fact, when we reviewed our common assessment and the midterm, free response number 2, part BII, I use this equation of a line. You also saw me use this in lesson unit 1, lesson 2, 3, 4, something like that. Point slope of a line. You need to know this formula. It is this, that f of x equals m time. Okay, you know it. X minus x1. Close. And plus y1. Yes, you need to know that formula right there. We call that one point slope. The reason we call it point slope is it gives us the slope and we plug in a point. And that's how we're going to use that. Now I want you to compare this to what we were doing in lesson 2.1. In lesson 2.1, I gave you an arithmetic sequence. And I told you the formula is this. It's AK plus the common difference, which we called the letter D, parentheses, N minus K. That was the formula I gave you. I know if you did your delta math, you would have saw a slightly different formula. I recommend you use this one because it's more powerful. Now, let's make some comparisons here. These two formulas are extremely similar. Like if you look, they both have something multiplying a parenthesis, something multiplying a parenthesis. They both have a constant being added. So with that in mind, let's line up which variables correspond to one another. For example, what corresponds to the slope in the arithmetic sequence? D, very good. So down here, I'm just going to put these down. M corresponds to D. Very good. All right, how about x? What corresponds to the variable x in the arithmetic sequence? N, very good. So x and n correspond to one another. Very good. Okay, what about x1? The k, very good. x1 is similar to k. Finally, what is similar to y1? AK, very good. I guess I could go one further. I could say what corresponds to f of x? Let me just slide these over so I have it in order. What corresponds to f of x? Yeah. You got it. All those correspond to one another. And here's the point, is that linear and arithmetic sequences are mathematically equal to each other except for this one fact. And you ready? And this is what you need to add to your notes. Arithmetic sequence is going to be discrete data. I'm about to tell you what that means. Whereas a point slope form of a line is continuous. So I'm going to start with the word continuous. Continuous means there's no breaks. So once you start drawing your line, you continue your line without ever breaking the graph. What discrete is it's data that looks similar to a scatter plot. It's just a bunch of points, but the points are not connected. So there's gaps in the graph. That's what it means to be discrete. So the only difference in these two things, a linear function and an arithmetic sequence, is how it'll look on the graph. One is continuous, the other is discrete. Okay? So I'm about to give you a picture in 2 slides of what this means. But before we do that, now let me introduce exponential functions. An exponential function, the way you're going to typically see it is like this. A times b to the power of x. And that's typically how you're going to see an exponential function. But, and this is a big but, when we do algebra, that, if you leave it very simple like this, it's not that powerful to us. So despite, if you open up your delta math, that's what it's going to tell you. I'm going to add something to it to make it more powerful, just like I did on arithmetic last class in 2.1. I'm going to do the same thing here. Here's what I want you to have for exponential. That this an exponential is a times b to the power of x. Put a parenthesis around that x and do minus x1. And I want you to put here that you could write it or f of x equals y1 times b to the power of x minus x1. Okay, now on this or, what did I change from the first formula to the second? A becomes y1, and that'll make sense right here. Usually we have x1 comma y1. Here I put x1 comma a. So what would that a typically represent? Y1. So I just substituted that in there. Okay. Now geometric sequence. Do you remember that formula from last class? Gn equaled gk. Wasn't a d. That was for arithmetic. R for common ratio. Very good. To the power of n minus k. Okay, so let's do our comparisons. So f of x will compare to what? What is f of x comparable to? Gn. What is a or y1 comparable to? A or y1 would be comparable to gk. Good. What is the base b comparable to? R, the common ratio. And x would be comparable to n. Finally, last one, x1 is comparable to, okay, you got it. Okay, once again, the only difference between exponential and geometric is that geometric will be discrete data. And what did I say discrete is?
It has gaps.
It has gaps. It's just going to be a graph of a bunch of points, a lot of points. Whereas exponential will be a continuous function. What does it mean to be continuous? No breaks. So this will be a curve, but it'll be a continuous curve. There will be no breaks in the curve. Okay, so I think I'm going to prove myself to be a liar to you. I told you a second ago in 2 slides I'll show you discrete data. I showed you that. I said that last class, or last slide, but I just remembered this next slide is actually what exponential functions look like. We have 2 different types of exponential functions. You'll hear me say growth, or you'll hear me say decay. What's the difference between growth and decay? Growth increases, whereas decay decreases. You need to know that. So an exponential function looks like this. I'll say either an airplane taking off or an airplane landing. That's how I'll describe how the graph looks. It is continuous. It does not stop. It approaches a horizontal asymptote, which means it'll flatten out on the x-axis. That is the horizontal asymptote. So these graphs will have a horizontal asymptote that it approaches. So it's almost like a runway, and the plane takes off the runway. If you've ever seen a plane, that's kind of the idea. It comes down the runway, and then it takes off. That's the idea. It never actually, hopefully, the airplane never actually hits the ground. It just stays right above the ground, and then it flies off. Same idea here. When the plane comes to land, it doesn't actually crash into the x-axis, hopefully. It just stays right above the x-axis there on its wheels. It just rides right above it. That's the idea here, and that's why I'm going to use an airplane to describe it. So an exponential looks like either an airplane taking off, growth, or an airplane landing, decay. Make sense? Okay, now let me show you the picture of continuous versus discrete. I have 2 images here. If you look at the equations, both equations after the equal sign is 2 times 1.3 to a power. 2 times 1.3 raised to a power. If you look at their graphs, if I tried my best to draw right on top of this curve here, I'm just going to stop there. I did my best. I know it's not perfect, but I did my best to trace. If I move this to the y-axis over here, what can you tell me about the relationship of these 2 graphs? They're the same. Okay, but what's different when you look at them? There's an obvious difference. This one has gaps. So what type of data is this? Discrete. Because it's discrete, I'm about to spell it wrong. Discrete. Because it's discrete, that means this is which one? Was it geometric or is this an exponential?
Geometric.
This is a geometric function. So underneath, I want you to put that this is a geometric. I said geometric function. You would call it a geometric sequence. That's what they would call it, a geometric sequence. As well, I have a typo on here. What is the independent variable in this equation here? Which one's the input? Is it the gn or is it the n? N. Okay, come down here. This says x-axis. It should not say x-axis. What should it say instead? n. There you go. And you could say y equals g of n. Okay, now come over here. Tell me about this graph. What can you tell me? It's continuous. Now, if this is continuous, is it a geometric sequence or is it an exponential function? This is exponential. And by the way, I knew it wasn't arithmetic / linear because it wasn't a line. Make sense? Exponential function, not functions. It's only one, it's not plural. Okay, with that, you're gonna have your first DOL. I want you to go to the back of the packet and try number 3, DOL number 1. All right, example 1. Let's take a look now at some of the math behind how we calculate these values. It says here, a function has the following coordinate points. Could the coordinate points represent a linear function, exponential function, or neither? So what I'm going to do here is show you, no, mathematically, if it's linear, it's the same work as if it said to solve it as it's arithmetic. Okay? The work is the same. Now, truthfully, a linear function means it's continuous. Arithmetic would mean it's discrete. But as far as the math goes, the math is the same. If it's exponential, what else would it be? The math be the same as? Geometric. They're one and the same types of math. Okay, the math itself is no different. All right, so here's how we go about doing this. If you're trying to determine which of it is, you have to have 3 points. You can have more, but you must have a minimum of 3 points. How many points do you have to have? 3. If you're going to determine what type it is, you have to have 3 points. So here I have 3. What do we do first when we're given data? Let's just pretend this is a non-calculator problem. What do we always do first if you're given data points without a calculator? I would do AROC. I would always do AROC. That's what I would do. I think it's the quickest way. Let's find our AROC. Do you remember what's the formula for AROC? Yeah, it's the change of y over the change of x. Okay, so here's what I'm going to do. I'm going to do the y's first. How much do my y's change? Actually, I'm going to get a different color so it stands out. How much do my y's change going from a 1 to a 4? A plus 3. Okay, and then how much do my x's change going from a 2 to a 3? It changes by how much? 1. Okay, now the x's should always be increasing, so I'm not going to do a plus there. They should always be increasing, but I will do it on the y because y could increase, it could decrease. So I change my AROC would be 3 divided by 1. Positive 3 divided by 1. And I'm not going to even worry about reducing. I'm not going to take the time. I'm just going to leave it like that, okay? Now, I can do AROC one more time. Let's now look between the second and third point. So said another way, how much does my y2 increase by to get to become y3? It increases by 12. Now, how much did my x2 increase to become x3? 1. Okay, so I had the first AROC of 3 over 1, and my second AROC is 12 over 1. Okay, first observation you could make when you look at this is whether or not it's linear or arithmetic. If these are constant, it's linear / arithmetic. If they're not constant, it's not linear or arithmetic. What can we state about our AROCs here? This is not a linear function / arithmetic sequence. Because why? The AROC is not constant. Make sense? All right, now let's talk about if it's an exponential or geometric function. I gave you a formula last time on lesson 2.1 for geometric. The formula was this, is that you find what we call then a common ratio, what we'll call today a base. I'm going to use base because that's what you see more often. The formula last time, the only thing different is I used a r. It's b raised to the power of delta x equals y2 divided by y1. That's the formula I gave you last time. I actually might have done it with a root on both sides, but this is basically the formula. Now I'm going to add something to this because if we're working with AROC first, there's something even better than this, and that's what I'm going to put equals to here. It's equal to AROC2 divided by AROC1. Now, I want you to make this note that this formula that I gave you last time is good. It is good. But I want you to make the note that this is better. Because in a couple lessons, we're going to start making the math complex. And AROC will work right away, whereas Y2, Y1 will require some changing of values. So it's just better if you have two AROC values to use two AROC values. It's a better formula for you. Okay, on this case, do I have two AROC values? Yes, so I'm going to call this one AROC 1, and I'm going to call this one AROC 2. All right, so define my base. I'm going to say B delta X. Now, what is delta X on our problem? Yeah, how much was my X's changing by? They were changing by 1. So B to the first power will equal AROC 1, or excuse me, AROC 2. What is AROC 2? What's 12 divided by 1? 12 divided by AROC 1, which is 3. So what's my base? 4. Okay, to see if it's exponential, you need to do a test. We need a test, and here's what we're testing. Does y1 times that base value we just found, does y1 times the base equal y2? That's the test. Is this a true statement or a false statement? So that's what we're going to test here. So I take my y1. What is y1 in our problem? 1. I'm going to take 1 and multiply it times the base. What did we just say the base was? 4. And ask, does that equal y2? What is y2? 4. Does that work? Yes. That means this is exponential. This is an exponential function. Or we could call it a geometric sequence, since it has a common base of 4. It has a common base. Actually, I'm going to put this in parentheses because if it has a common base, it's exponential. It doesn't have to be 4, but in this case, it was 4. So this is an exponential function or geometric sequence. That's what it is. So it has to determine what this function is. That's what it is. It's an exponential function, or you could call it geometric sequence. Okay, now that was a lot there to see it on the first time around. So I have 2 more to show you before I move on and make you try one of these, okay? Let's see this again. Am I going too fast if I go to the next slide? All right. This is exponential because it had a common base. When we did our test, it worked out. And so it passed the test. Therefore, it was an exponential. All right, let's look at this one. How many points did they give me? Is that enough to determine what it is? You bet. All right, what did we start off? What did we do first last time? AROC. We're going to do that again. We're going to find our AROC. So change a Y goes first. You always do rise before you do the run. What's our rise going from 3 to 7? And what's my run going from 5 to 6? 1. So I have a plus 4 over 1. Now let's find our second AROC. So from Y2 to Y3, what's the rise? From X2 to X3, what's the run? Okay. What can you tell me when you look at those AROCs? They are not constant. I'm going to add in a little divider here because when I write this in. Not constant, therefore, AROC is not constant. Therefore, not linear / arithmetic. Good. Y'all are doing great. All right, so what do we do if it's not arithmetic or linear? We see if it's exponential. Okay, so do you remember the formula I just gave you? It's base raised to the power of what? Delta x. What's our delta x? 1. Base raised to the power of delta x equals, you could do y2 over y1, but there's something better than y2 over y1. What was better? AROC 2 divided by AROC 1. That'll be more powerful if you have it. So we'll do that. We have it. It's 3 divided by 4. That's our base. That's fully simplified because b is to the first. We can be done there. That's our base. So how do I test now? We're going to take our y1. We're going to see if y1 times the base equals y2. That's the test. Is this a true statement? That's what we're trying to find out. What is our y1? 3. So 3 is y1 times what's our base?
3/4.
3/4. We want to know, does that equal y2? What's y2? 7. Does that equal 7? No, that's not a true statement. This is wrong because this is not, if you're not sure, 3 times 3, the way a fraction works, you multiply the top. 3 times 3 is 9. Divide that by 4. Is 9 divided by 4 7? No. Since that is not true, guess what? This is neither. It's not exponential. Neither linear nor exponential. Questions over that one? All right, one more time. I'm going to have you walk. We're going to work through this one more time, and then I'm going to let you try one. All right, how would we start this problem off? Let's find our A rock. What's the change going from y1 to y2? Plus 8. What's the change in going from x1 to x2? Okay, so it'd be positive 8 divided by 2. All right, tell me now, let's change from y2 to y3. What's the change there? Plus 8. What about x1, x2 to x3? That's a 2. Okay, so we have 8 over 2 divided and 8 over 2. What can you tell me about those A rocks? They're constant. So this would be, this is a linear function, or what else could we call it? Arithmetic sequence, since A rock is constant. Underline all that. There it is. That's what it is. I guess I need to underline this answer. Okay. Get the L. There we go. So with that, you see me do it 3 different times. You've seen one result of each. I want you to try DOL number 4 in the back of the pack. Now, if you finish early, you can try number 6. Number 6 is very similar. Now, here's the deal. Everyone I've shown you today has been 3 points. So if they don't give you 3 points, which is going to be the case on number 4, you're going to have to plug in your values and see which formula actually works. So if they don't give you 3 points, which is going to be number 4, you're going to have to plug in to see if it actually works. So go ahead and try that. All right, example 2 now. If we know, so let me back up. On the last problem, I said how many points you have to determine what type of equation it is and define the equation. How many you have to have? 3. If you know what type it is, meaning if you know that it's linear / arithmetic, you only have to have 2. If you know that it's exponential or geometric, you only have to have 2. You have to have 3 if you're trying to determine what it is, if that makes sense, okay? You have to have 3 to determine. Now, on example 2, it says this. If we know that a function is linear or exponential, then only 2 distinct values are necessary. So you only have to have 2 if you know what it is. So on AI, it is known that f of x is linear. What is f of x? Linear. Okay, so we're working with a continuous linear function this time that passes through these points. Write an equation. So if you know it's linear, you don't have to do any of those checks. You just do the math. What was the math that we did first to determine if something was linear last time? Do you remember? What did we do first when we were trying to determine if it was linear? A-rock. You're still going to do A-rock because A-rock's how you determine linear functions. So what's the change in my y's going from y1 to y2? I subtract 6. What's my change in my x values going from x1 to x2? Positive 5. Okay, so my a rock is negative 6 over 5. Here's what you need to know. For a linear function, that is your slope. That right there is your slope. And if it was said arithmetic, we would say it's the common difference, D. Okay? The a rock becomes, your a rock is the same thing as slope, and it's the same thing as a common difference on an arithmetic sequence. Okay, they're all one and the same. So there it is. My a rock is negative 6 over 5. So if we're going to write an equation, we need to know that point slope formula. Do you remember the point slope formula I gave you earlier? M. Y'all have to have this memorized. You gotta start working on memorizing this one. X minus x1 plus y1. Okay, if you found your a rock, you should have all the pieces necessary to write this equation. I have not labeled it. Tell me what value up here is x1? 3. Good. What is y1?
7.
And with that, we have everything we need. Well, we could say the equation is f of x equals, what's our slope? Negative 6 over 5 times x minus 3, because x's are liars. This positive 3 becomes a negative 3. And then plus 7. There's your equation right there. That's our equation. Now, what I'm going to do here, this part 2 would be you'd be allowed to use a calculator on this part. So before we move on to this DOL, I'm going to remind you how to use your calculator on this. So open up your calculators, please. Go home screen, new document. Home screen, new document, don't save. And I want you to add a graph. Now, this problem has nothing to do with graphing, but I want to store this equation of f of x. So hopefully you cleared your calculator like me, so you're seeing f1, and I want you to type this equation in. It is negative 6 over 5 times x, the quantity x minus 3, plus 7. Type that in, press enter. Now, what shape is the graph? What shape? It's a line. Should that be surprising to anybody? No, that's what we were trying to find. Let's line. Now, to find F13 minus F18, there's a calculator way of doing this. Anybody remember? Well, this is a calculation. Where do I make this calculation? I need to add a page. How do we add a page? Control dot, hit add a calculator. And instead of f of 13, what are we actually going to type in? Oh, come on. I've shown you how to do this multiple times. What do you type in the calculator? What is this stored as a calculator as? F1. I want you to type in F1 of 13. And then we will subtract F1 of 18. You can press enter. And while you do that, I'm going to show you multiple ways students might mess this up. Students might say F1 parentheses 13 minus 18. Students might say F1 parentheses 13, close your parentheses, minus parentheses 18. All these things are incorrect. The correct answer on this particular problem is 6. The correct answer is 6. But I'm showing you here how students might do it wrong. Notice this one looks almost identical to this. What's the only thing I changed? Yeah, I put in a 1. Why do we put F1? Because that's how it went into the graph. I guess I should post that. Now, with that, you can go ahead and start number 1 in the back of the packet. You can go ahead and do that. I'm going to add in on the notes here this picture, but do number 1 now. All right, let's continue on with example 2. So now, remember how I told you, if you don't know what type of function it is, you need how many points? 3. If you do know what it is, you only need 2 between exponential and linear. So it says here on BI, it is known that g of x is an exponential function. G of x is an exponential function. Now, if you're writing an equation by hand, I think the easiest equation to use is this one that I gave you. Instead of an a, to do it this way. This is, I think, the easier formula to use if you're writing it by hand. Now, they're not going to ever show you a y1. What will they do in place of y1? They will give you an a. That's what, if you're doing delta math, do not be surprised. They will every time give you an a. They will never give you y1. I'm going to do it that way just because it makes this formula more powerful. If you memorize this, you'll be able to solve problems quicker. Okay, so that's what I'm going to do. So it says it passes through these points. So do we already have an x1 and a y1? Yes, we do. So what do we need to find to have our equation? B. So do you remember what I told you? B is you raise it to the power of what? Delta x. And then you can use AROCs, or you could also use, and that's what I'm going to do on this one. Just because I don't want to have to do extra, I'm just going to use this formula because that one does work. So first question, how much does my x actually change by? 2. So this will be b squared equals, now what's y2? 12, and you divide that by 5. We're a step away. The only thing left to do is get rid of this squared. What is the opposite of a square? A square root. So if I square root both sides of the equation, I should have my base. My base is going to equal the square root of 12 divided by 5. So the equation we're going to plug in our calculator. So we're going to say g of x equals, what's our y1 or our a value?
2.
Not 2.
5.
5. There you go. 5 times. Now the calculator is going to do a parenthesis, so I'll go ahead and add a parenthesis here. Square root of 12 over 5 raised to the power of
2.
x minus 2. Very good. The reason I put a parenthesis there is when we press enter in the calculator, it'll put a parenthesis there. So I'm going to go ahead and just leave it since that's how they're going to make it be. Okay, so calculator time. Home screen, new document again. Clear out. We don't need the old stuff. Let's just clear it out so that we can all use the key F1. Where do we type in an equation again? Add a graph. 5 times parentheses square root of the fraction 12/5 and raise that parentheses to the power of x minus 2. Now when I press enter, should I see a line?
No.
No. This is exponential. Okay, does this like a exponential growth or exponential decay? This is growth because it's increasing. It's like a plane taking off, okay? How do I solve part 2? Add a calculator, so control dot, and what do I type in? F1 parentheses 6. Hit enter, and there's your answer. If you wanted to check this, you know how you could check it to make sure you did it right? I could type in F1 of 2. Let me make sure everybody in the room is following along. If I press F1 of 2, if I type in F1 of 2, I'm saying the input is 2. What should I get for the output? 5. Good. Let's press enter and see if we get that. Do I get 5? You bet. And if I wanted to check it again, what if I gave an input of 4? What should the output be?
12.
12. Do you see how that works? So we did it correctly. Everything mathematically is working. All right. With that, you have your next DOL. Go try number 5 now. Try DOL number 5. The fun stuff, real world applications. How many of you, show of hands, want to buy a house someday? Unless you have the money to buy it in cash, which I don't know anybody, students wise, who ever do. I didn't myself. You have to buy it with a loan. A loan is based off an exponential function. Okay, different question. How many of you want to buy a car? Now, some of you might be able to save up the money to buy a vehicle without a loan. But if you're going to use a car loan, it's going to be an exponential function. How many of you already have a credit card on you right now? I do. Those are exponential functions. Most of the more important things financially The more important financial decisions you make in your life are going to be based off exponential functions. Here are two formulas that we might use. Now, here's the difference. If you read these closely, they tell you what all the variables stand for. I'm going to tell you the key thing right here. The top formula we use whenever the value is compounded a certain number of times per year. Now, right now, that probably doesn't mean much to you, but I'm going to give you some illustrations. It'll make a lot of sense really quick. What compounded means is how often do they calculate the interest? Or, thought of another way, how often does someone require you to pay them? So, let's take an example of buying a house. Does a bank require you to pay them for your house every moment of every day? Or do they only require you to make payments a certain number of times per year? Answer is a certain number of times per year. How often do you have to pay the bank for your house? Once a month. N would be 12 because that's 12 times per year. You have to make 12 payments per year. Does that make sense? Let's talk about you buying a car. You buy a car and you get a loan from, let's just say it's Chevy. Do you have to pay Chevy every moment of every day, all year, or do you only make a certain number of payments per year? Certain number of payments per year is probably, again, monthly, so 12 times over the year. Okay, let's say you buy into a company. By the way, companies, the way they make money is exponential. You buy into McDonald's. Does McDonald's make money every moment of every day, or do they make money only certain points in time, a certain number of times per year? Every moment, every day, which means they would be a compounded continuously formula. Continuously means it's happening all the time. So business growth, businesses typically grow from this formula. You're going to hear me say A PERT. Why will I say A PERT? Look what the formula looks like. It looks like PERT. That's the one that's easy to memorize. This one, you're going to have to think on for a little bit, and you're going to have to practice this one. This one's one of the harder formulas you'll have to get down. So those are our two formulas we're going to use. So let's start here with this first example. Mr. and Mrs. Jimenez found an educational savings account for their daughter that pays 5% interest compounded monthly. If they invest $5,000 for their daughter and make no other deposits or withdrawals, what will the value be of the account after 18 years? Here's the idea. You're born. What are y'all, mostly 16, 17, 18 years old, somewhere in there? If that's y'all's age, then think about when you're born, your parents looking at you going, hey, I need to start saving up for their college right now. And that's the case of this problem. They invest $5,000 into an account, and they're going to wait 18 years. Newborn baby will wait till they're graduating high school around 18 years old so they can use it for college. That's the idea. So here's the idea, or that's the idea. Now, what formula do we use? What you do is you find the word compounded and you look at what it says. This says what? Does that mean every moment, every day, all year, or a certain number of times per year?
Certain.
If it says monthly, it means monthly means what? 12 times a year. Okay, so make sure you put down n equals 12 here. Monthly means n equals 12. And the formula we would use, I'm going to assume you don't have it memorized yet. It's a equals p times 1 plus r divided by n, all raised to the power of nt. That's our formula we're going to use here. So once you find out the formula, now it's time to determine what variables they gave us. So I'm going to start here with 5% interest. What do you think 5% interest is? Do you think it's A, the final amount, P, the initial amount, R, the rate, N, the number of times per year, or T, the years? What do you think 5% interest means? The rate. Okay, so if R is 5%, how we'll actually type that in the calculator is 0.05. You move your decimal 2 times to the left. This doesn't have one, so I add one. You move it 2 times to the left. So around the 5, and then you create a spot for a 0. That's what our R will be. Okay, next value I see up on the board is this invest $5,000. Is that the final amount, the initial amount? Is that the number of years? Those are the only variables left. That's our P. We're going to say P is 5,000. And finally, we have 18 years. Is that The final amount or the time? That's T. T is 18. Okay, so we plug in our values. We do not know our final amount, but we know the initial amount was $5,000. Your parents put that in the account, they don't touch it. They let it sit there. You go through your grade school. You go through first grade, second grade, third grade, fourth grade, fifth grade, all those grades. And then you graduate high school. And then you go to your account and your parents say, yeah, I put in $5,000 for your college. You have $5,000 to work with. And you're like, great. And then you open up your account. Is it only going to be 5,000? No, it was making interest. And so let's see what your 5,000 turned into. So I'm going to just type this right side in. It's 5,000. You go ahead and follow along with me, please, in your calculator. 1 plus. Start practicing typing these in. Make sure you are doing it correctly. All right, I'm going to press enter. Because we're dealing with money, I'm going to write down, I'm going to round it to the nearest hundredth, because that's money. That would be pennies. I'm going to round to the nearest penny here. What are you getting as your answer? That's right. Hey, that's not bad. That's not bad. College is expensive. Don't get me wrong, but $5,000 turned into how much money? And how hard did your parents have to work for this extra 7,000 that's now your money just gained? They didn't have to work at all. They just put it in an account. Now here's the deal. This was an educational savings account. If you don't know, educational savings account, they are very low risk. But a term you might hear if you're in a financial class like economics is low risk usually comes with low reward. The higher the risk, the higher the potential reward, but you also, the higher the risk, the more you can lose it. For example, the highest risk I know of would be gambling. If you go to gamble right now, you can buy a $2 lottery ticket and you could go buy either the Powerball or the Mega Millions. And you have a potential right now winning $358 million off of how expensive of a ticket?
$2.
$2 can turn into $358 million that fast. Now it's extremely high risk. Why is it high risk? Because when you buy that ticket and you pick all your numbers, if just one number misses, you get nothing. You might get your $2 back. Maybe you happen to win a little prize, you get your $2 back. But it's extremely high risk, which means you might lose it. All right. What's a safer way of having high risk? I would suggest looking into individual companies. So now that's what we're going to do. Part B here, we're going to look at Google. So Mr. Rangel purchased a stock in 2010. The cost of Google, and I put in parentheses here, if you actually wanted to look into buying it, this is what you would type in. So I want to do a little exercise with you. Pull out your cell phones. Now, I want you to type in Google spelled the normal way. What happens when you type in Google and you spell it the normal way? Google. And you hit enter. What's going to happen? It takes you to the search engine. It's going to take you right there. All of a sudden, my computer's going really slow. Well, you know, you've typed in Google before. You know what's going to happen. It's going to take you to the search engine. Now, if you type in something and you misspell it, oftentimes, when you type something in and it misspells it, it'll say, did you mean, right? So it makes sense if you typed in Google, but you forgot the E, that it might say, did you mean Google? But that doesn't happen. What happens when you type in Googl and then press enter? Does it say, did you mean Google? No, it pulls up its stock. Now, Alphabet's the name of the company that actually owns Google. If you can look at it, it pulls up the stock. So what I'm showing you here, I'm not just making up something random. I'm showing you if you wanted to buy a piece of Google, the company, that's what you would use, the Googl. Does that make sense to you what that is? It's not a typo. That's what you would actually look for. Okay, let's do the problem. The cost of Google was $14.90 on January 1st, 2010. That's a fact. On September 29th, 2024, the price of Google was $165.29. That's also a fact. Using the continuous compound interest formula. Okay, I want to pause. They just told us which formula to use. It says continuous. Does that mean it happens a certain number of times per year, or it's happening all the time? What does continuous mean? All the time. That's the formula A equals PERT. A equals PERT. Says find the rate of interest for Google over the approximately 15 years of growth. Okay, so let's put this in. I'm going to go through here. The first value that matters to you is this $14.90. What is the $14.90 in this problem? Is it the final amount? The initial amount? E, you're going to learn, is like pi. E is a number. It's not a variable. Is it the rate or is it the time? That's our P. P is going to be 1490. Okay? The next value I see that matters is not the date. The next thing that matters is this 165.29. What is that?
The final.
That's the final amount. 165.29. Now we're supposed to find the rate of interest. So what are we finding? What's going to be our variable? The R. That means I still need to have T. Oh, there it is. T is 15 years. And they just say approximately, which means we can just round it to 15. We don't have to do the exact. Okay, so let's type in our values and see what we have. Our A is going to be 165.29. Our P in the formula was $14.90. E is a button on the calculator. I'll show you. It's like pi. We don't know our rate, but we do know time is. Okay, what I'm going to do is I'm just going to insolve it. I will show you in the coming days how to solve this problem by hand. Today, I'd rather teach you how the finances work rather than teach you how the math works on this. Okay, so that's what I'm going to choose to do here. Let's open up. We're going to go, I'll clear out my calculator. This right now is not solved for R. Since R is in the middle of this, I'm going to have to insolve it. Press menu 3-1. Menu 3-1, that gets up insolve. 165.29 will equal 1490. All right, E. Don't press the E on the keyboard at the bottom. Press E. That's the two buttons to the left of 1. It looks like E to the power of X. That's the E you need to click. If you click that E, it does a bold E. And we're going to do rate times 15. If I press enter right now, it'll give me an error. Some of you who is not a insolve rookie, what's my thing that I need to add? Comma R. Press enter. What do you get for the rate? Are you getting 0.160? So on? All right, great. That means this has been growing. College Board requires 3 decimals, so I'm going to put 0.160 here. This has been growing at 16.0% a year for those approximate 15 years. Okay, so here's the idea. Remember the last problem? It grew at 5%, and $5,000 became $12,000. Okay, now we're investing, and $14 became 165. Look, our money got multiplied by more than 10, and it did it in a shorter amount of time. Now, how did that happen? When the last one, it got multiplied by a little bit more than 2. 5 turned into 12, so it got multiplied by a little bit more than 2. This time, the money got multiplied by more than 10. How did that happen in a shorter amount of time? Answer, the interest rate. The rate makes a big difference, okay? Let's start part 2 now. If the stock continues at this growth rate, okay, what is that telling us? What's that telling us right there? The rate's going to stay at 0.160. And Mr. Rangel's initial investment was $3,000. Okay, now what's that telling us? The P. In 2010, what will his stock be worth at the end of 2030? Okay, what is that telling me now? The time. What is T going to actually be? 20 years. Now, why is it 20?
So this had 10.
Yeah, 2030 minus 2010 is 20. Okay, so now we're going to plug in our formula. So same formula, A PERT, but this time I'm going to, R and T are power, sorry. This time, I don't know my A, but we're going to say the P is 3,000, E to the power of 160 times 20. Does everybody make sense?
Mhm.
So you should know that the money should at least get multiplied by more than 10, because that's what happened here. So let's see what $3,000 turns into after 20 years in Google. Okay, so I'm going to type this in, 3,000. I'm hoping y'all are typing these in so you see the numbers yourself. Times the rate. Now, I don't want to have a rounding error, so I'm actually going to just copy this value of R straight in. I'm going to just highlight it and press enter, and it'll copy it down. So I put in the whole rate because I want to get the exact value. I don't want a rounded answer. I want the exact value. And then I multiply that times 20 because we're leaving it in for 20 years. Press enter. What do you get?
73,500.
Okay, you use the rounded version. If you did not round, you got even more than that. How much did you get if you did not round that rate? If you copied and pasted it? $74,000. Oh my goodness. I want you to think about this. Right now, if you went out next summer and you worked all summer, legitimately, how much money do you think you might be able to save up? I hear somebody say 1,000. Yesterday I was here, most people center around somewhere around $2,000. If you worked all summer, you might be able to save up $2,000. Well, this individual took 3,000 and they sat on it in Google for 20 years. If you take your summer earnings and you sat on it for 20 years, that means you didn't touch it. You just put it in Google. Everything you earned all summer, you're flipping burgers, McDonald's, you earn yourself $2,000, you buy their stock and you leave it alone. Or in this case, you earn $3,000 from flipping burgers. You go buy Google and you don't touch it again until you're my age. So your late 30s. How much is your money now worth?
74,000.
$74,000. $74,222.40. Isn't that amazing? Now that right there is the power of exponential functions. Everyone in this room, believe it or not, you could become a millionaire. You're gonna, some of you are gonna be rolling your eyes at me. You could be if you invested wisely in companies, because this is what companies do. Companies make money. Now, how hard was Mr. Rangel in this problem working for that $74,000? Nothing. He only worked for how much money? How much money did he actually work for? 3,000. But yet it became 74,000 because he invested in the company rather than just buying the next iPhone or the next set of earbuds or whatever else we like to buy. Spending it at the fair. He bought Google and it turned into 74,000 after a little bit of time. All right, let's do another one. Maybe it's not just Google. Let's see if this works for other companies. Ms. Hernandez owns stock in Apple. And again, if you want to look it up, you type that in Google. Google will not think you're misspelling it. It specifically will think you're wanting to buy the company Apple. She owns 220 shares, each valued at $227.79 on September 29th, 2024, for a total of $50,000 plus some change. If Apple has grown at 22.4% interest compounded continuously since her initial investment, how long has she owned the stock? So how much in this problem did Ms. Hernandez actually work for?
5,000.
There it is. I've added some stuff to try to make it confusing. Yeah, that's how much she sure worked for. How much is it worth? It's now worth 50,000. We want to know how long did she had to sit on it for it to become that? From 5,000 to become 50,000. That's the point of the problem this time. Okay, which formula are we using?
Compound continuously.
Okay, which formula is compounded continuously? That's because continuously means it's happening. Does Apple only make money on Sundays? The opposite of Chick-fil-A? No, they make money all the time. You can go online right now and buy some stuff from them. Okay, so that's the formula we're using. I threw in some extra information. Tell me what you think is really important to this problem.
The rate and the
I hear rate. That's important. So 22.4% is the same thing as 0.224. You move the decimal over twice. Okay, what else is important? What's the 5,000? That's the initial. And the 50,000 is important. That's our A. So what's the 220 then? Nothing for our problem. Matters nothing. All right, we plug in our values. So 50,113.80 is our final amount. P is 5,016 and 65 cents. E, the rate is 0.224 times what? How long?
We don't know.
That's what we're trying to find. Will this be an insolve or just typing it straight in? Insolve, yep. So we'll learn how to solve that in the coming days, but right now, it's just an insolve. Okay, I just wanted to make sure before I deleted that, I added it in. Okay, so we're doing insolve again, mini 3-1. We have $50,113.80 equals $5,016.65. E, use the E, that's 2 buttons left of the 1. The rate is 0.224 times T. Again, if I press enter right now, it'll give me an error. What am I missing?
T.
Comma T. And we get that this has been 10.274 years. Yeah, if you want to round, you can go, but I'm just going to truncate because that's what College Board does. So I want to say 10.274 years. I will do the squiggly equal sign like that since I'm rounding 274 years. That's my answer here. So 10 years of doing nothing except leaving your money with Apple made your money go times 10. Whatever amount you had, it would have gone times 10. That's the idea there. Pretty cool, isn't it? Some of you are just staring at it. Okay, stay broke. Whatever. Wear it. All right, part 2. If the stock continues at this growth rate, what does it mean if it says continues at this growth rate? What is that telling me?
That the rate is still the same.
The rate is still 0.224. And Ms. Hernandez does not make any further transactions. What will be the value of her shares in Apple be after another 10 years? Okay, so if it says another 10 years, we would think of our time being 10. But if it says after another 10 years, what's happened though is the P has changed. The P is not the initial amount of 5,000. What's our initial amount now? It's now the $50,113.80 because that's now the present value. So you can think of P as being present or past. In this case, it's the present value. That's what our current evaluation is. We'll take it to the E. The rate is 0.224 times 10. So we want to find out what's going to happen to this after another 10 years. Well, we already saw from over here, it's approximately going to get multiplied by how much after 10 years?
5,000.
This 5,000 became 50,000. You see how it got times by 10? After 10 years, so another 10 years, it's going to be close to being multiplied by 10 again. That's what's going to happen. All right, let's type this in. Do I need to do an insolve this time? Nope, because our variable's already isolated. There it is. I'm getting $470,735.52 or 53 cents, depending on if you want to round. That's incredible. How about that? How much money did Miss Hernandez work for in this actual problem? She worked for 5,000, and she bought Apple at the right time that had all this growth, and so she ended up without touching it for 20 years, which means basically you sitting in your chair, if you go the next 2 summers, I'm speaking to you as if you are a junior, you spend the next 2 summers making your money, and you don't spend it, you put it in Apple, and Apple grows at the same rate. When you're my age, you're sitting here, you're 38 years old with 5 kids. If you haven't touched your Apple shares, your $5,000 that you made from flipping hamburgers at McDonald's has turned into how much money? $500,000 nearly. Now, if you want to get wealthy, that's how you do it in America. You buy successful companies and you let it ride there. You don't spend it on gambling tickets. You don't spend it on buying the newest iPhone. You let your buddies buy the newest iPhone and you just buy their stock. So that every time your friend buys their phone, ching, you're getting paid. Make sense? That's how you do it. All right. DOL number 2. Let's do DOL number 2. All right, example 4, the last one I want to look at. And this one's really more for your benefit, not necessarily for AP curriculum. But it says this: the Gonzalez are purchasing a home valued at $350,000. The mortgage rate, which we can call APR, as of September 29th, is 6.153% on a 30-year fixed loan. If the Gonzalez put down 20% at closing, what will their monthly payment be? So I want to walk you through what happens when you buy a home. If you want to buy a home and get the lowest interest rate possible, which would mean the lowest you'd have to end up paying the bank, the number you're going to try to get down is what's called 20% down payment. What that means is you're going to need to pay this much, 20% of this at closing. Closings when you actually make the purchase. And so 20%, we would say that's 0.20. If you multiply that point, what you'll get here is $70,000, okay? So what that means is if you want the best possible interest rate on a loan, you need to have at least $70,000 to pay at the time of purchase. Now, what you'll do is if you have that to purchase, what that means is your loan, the loan amount would actually be 350 minus that 350,000 minus that 70,000 of 20% down, which would mean you'd be taking a loan of 280,000 from the bank. Okay, so if you want to know what will my monthly payment be, how much will I have to pay per month, you use this formula. So the monthly payment would equal MP, the monthly payment would equal the principal amount of the loan, which we're going to say is 280,000. One more zero, there we go, 280,000 times the rate. Now, if this is the rate, that rate is 0.06153. 0.06153, all divided by the number of payments. What you do is you make a monthly payment. So right here, this monthly payment means that N is 12. And we're going to not raise that one here, but down in the denominator, you'll have 1 minus 1 plus. I know you can't cancel those out. The rate again, 0.06153, divided by N, which is 12. This raised to the power of negative 12 times the time. And now the time is here, this 30-year, that is T. For 30 years, you're making this payment. So if we type that in the calculator and press enter, you can find out what the monthly payment price will be. And so I'm going to do that now. And need the calculator to load. All right. So our formula was 280,000 times the rate of 6.153% divided by 12 over parentheses 1 minus parentheses 1 plus. And now we do fraction of the rate again divided by 12. And this is raised, I believe it's the inside parentheses, yep, is raised to the power of negative 12 times 30. And press enter, I see that my, in terms of dollars and cents, my monthly payment will be $1,706.38. $1,700.38, I believe is what it was. Let me check that again. $706. $706.38. So now, what is the final cost of the home for the Gonzalez after 30 years of making their monthly mortgage payments plus the 20% down at closing? Okay, so here's the idea. You're making 30 years of payments. So it'll be the time times the frequency of how often you make the payment towards the payment itself. I'm going to say M fee per monthly payment plus the down payment, which I'll call DP, which is 20% down. So the time is 30 years. That'll multiply with the frequency, which is once per month. We make that monthly payment of $1,706.38 plus the down payment of $70,000. That's what I'm going to put in the calculator now to find out what the actual cost of this home is. So we thought we were purchasing it for $350,000, but by the time we're paying the bank, let's see how much it turns out to be. So for 30 years, we're making 12 payments per month, and the payment is $1,706.38. Plus, we put down $70,000 up front when we went to purchase the home, and that brings us to a total price of $684,296.80, which means our home has just about doubled in price from what we thought. Which is really something to be aware of, that when you go to purchase a home. Now, I don't say this to scare anybody away from buying a home, because, if you're renting, you're still paying someone some money and you're not getting any equity out of it. So I think purchasing a home can be a wiser choice if you can afford the payments. But I want you to realize that whenever you see a home, don't think, well, I can afford a $350,000 home, and think that that's all you'll ever pay. The truth is, in this example, you'd end up paying almost double the price, almost $700,000 by the time you became the actual owner, the true owner of the home, rather than the bank owning it and you just getting to call it your own home. So with that, that's a wrap. Go ahead, finish up any of the leftover DOLs you haven't done. Specifically, number 6 is probably one you haven't done yet.